Class example 3.4.7. This graph shows the approximate height of the tide as a function of time at Port Clemens in Haida Gwaii on June 17th, 2009. Okay, a couple of things to note here. Time is being represented by T and height is being represented by H. We've got units of meters and it looks like we're going in hours here for our time. We, just like in our last question, okay, we are going 9 o'clock, 10 o'clock, 11 o'clock, 12 o'clock, 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock. So this is on a 24-hour clock, which is okay. We see that the time is along the x-axis, our height in meters is along the y-axis, and they've only taken the time in between 9, 10, 11, 12, 1, 2, 3, 4 o'clock, but 4 o'clock. So I'm just going to write 9 a.m. to 4 p.m. just for my own sake here. And that's 13, 14, 15, 1600 hours. Okay, so nice, easy to count up. And that's why the scale sometimes for time uses 24-hour clocks rather than the 12-hour clock that we tend to use in North America. So it also looks like our height, it goes in between two values here. We'll figure that one out. And same thing here. So our scale's not perfect, but that's okay. It looks like each one of my steps is 0.2, right? So it goes 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, that kind of thing. So if I know that we look like it's about 0.2 for each scale along the y-axis, let's go, this looks like it's probably about halfway in between and halfway in between, so maybe 0.1 units. Okay, so if that's the case, that looks like 0.1 above 0.8 is going to be 0.9, and then all the way over here, that's 1.4, this must be 1.5. So let's go with those approximations, and it did say approximate in here as well, so we're okay with that. Okay, now that we've kind of interpreted the graph, we could look at the questions. I always like to interpret the graph first, get my head wrapped around what the information is telling me, put it into my own perspective, and then I can go ahead with the questions. Now, the only other thing that we haven't quite done here is talk about the height of tide. Now, we know that as time goes on, the water levels will rise and fall in the ocean. And so in this particular case, it looks like we started with a low tide. We had a high tide up here. And then it goes back down to the same water level. I believe this is based on moon cycles, but don't quote me on that. Okay. Question A says, identify the dependent variable and the independent variable, justify your choices. Well, we're kind of lucky on this one. We've already done so, right? We've talked about it already. And that's why I like to interpret the graph before I get to the questions. We already know that the independent variable is something you can't manipulate, right? It's not dependent upon something. Time is something that we can't manipulate. Not yet, anyway. Another thing that's kind of nice about that is independent and input. Pretty darn close. We also know input is along the x-axis, which will eventually become our domain values. So our independent variable is time in this question. Our dependent is what happens as time goes by. Well, that's our output. That's along our y-axis. That's what we're going to get to our range. And in this particular case, it's height. Okay. The purpose of this was to talk about that time as being our domain and height as being our range. Okay, question B. Why are the points on the graph connected? We've talked about this a little bit before. We're talking about time and we're talking about height and we're talking about things being connected. We're not actually having the individual dots. Oh, even if those were actually the only times that they actually chose to measure the height. And it's because time is continuous, right? That says time. right? Time is continuous. You don't get to tell the ocean, hey, wait a second, just jump over to 10 o'clock and then give me your height. Oh, wait a second, let's just wait. Hold on, I'm just going to magically teleport to 12 o'clock. That doesn't work, right? We have all of the minutes and all of the seconds in between 9 o'clock to 10 o'clock to 11 o'clock, all the way up to 4 o'clock. So time is continuous, and this is why we are connecting those lines. Height is actually also a continuous unit of measurement. Okay. The ocean doesn't just start at 0.9 meters deep and then magically just jump to 1.5 meters deep. Over time, it hits 0.9, 0.95, 0.99, 1.0, 1.3, 1.7, whatever it happens to be all the way along. It has to actually gradually increase and gradually decrease, and it hits all of those units of measurement. And this is why we connect the lines. For question C, domain and range, well, we know our time is going to be our domain. We've talked about that already. And our range is going to be the height. So for our domain, I'm going to go with the easiest. I hope you don't mind. Our domain, we're going to go on the 24-hour clock. We started at 9 o'clock and we stopped at 1600. And so I'm actually going to say 9 to 1600 hours is my domain inclusive. Nice, easy interval notation. In our range, we kind of already talked about this as well. We went from 0.9 meters all the way up to 1.5 meters. And there is my domain and range.